This video is the 2023 higher level question B2, which is a planes question. So looking at the question, figure B2 shows the plan and elevation of two intersecting planar surfaces A, B, C, D and B, C, E, F. There's four parts to this question. Part A is to draw the given plan and elevation of the intersecting planes A, B, C, D and B, C, E, F. Part B is to determine the dihedral angle between the two planes. Part C, there's two parts to it, so point P is a point on the edge BC, which is located at a true distance of 55 millimeters from point B. We're asked to draw the plan elevation of the line DP and then determine and indicate the true length of DP. For part D, the question is to determine the true angle between the edges AB and BF. So starting this question, you basically need to start in the plan. There's very little you can do in the elevation. You can just about find the line EF and nothing really more than that without doing the plan first. So you're going to have a 25-degree line somewhere down in plan. I'm just going to pick a point down here somewhere, which will be my starting position. And I'm going to measure 25 degrees down below that. Now we're told it's 55 millimeters across this distance here. So using sliding sets, we're to get my 90-degree angle. And I can project down this side of it also. We have 50 millimeters down to point C, and then a further 30 down to point B. Now we're also given a 75-degree angle from point C here. So I'll line it up along here. 75 degrees is this one. And that gives me point D. We don't have enough information in plan to get point A yet, so we're going to have to draw the elevation to get that one. E. So we're going to project all these points up into the elevation now. Point E is on the ground. F is 50 above that. There is F, and B is going to be 35 above that, so 85 total. So that's B, E, and F. C is on the ground, so I can join B to C. And then for A, we're not given the position of it in measurements, but we are given that it's parallel, or the line DA is going to be parallel to the line CB, so I'm going to go parallel to that one here from D, so it's out along this way. So A is going to be somewhere up along that line. It's at an altitude of 60, so I'm going to measure up 60 above my XY line, and then just take that horizontal line across here to A. This here gives me A. So A to D and A to B. So that finishes the elevation. I still need to find A down in plan, so I'm just going to project that point that I've located up in the elevation down into plan where it intersects the line from C or from D, gives me the point that I'm looking for. And that completes the first part of the question, which is to draw the given plan and elevation of the intersecting planes A, B, C, D and B, C, E, F. So the second part of this is to determine dihedral angle between the planes. the planes are A, B, C, D, and B, C, E, F. As B and C are common to both of those planes, as in A, B, C, D, BC is there, and B, C, E, F, BC is there. BC is the line of intersection. It's just a handy way of identifying which line we're looking for. We're going to take a line perpendicular. We need to find an auxiliary. We need to find the true length of the line BC first to get our dihedral angle, and then we're going to look along a point view of that same line. So I'm going to start in plan. I'm going to take a line that is an x1, y1 line. So I have my x, y1 line here. This is the xy line. I'm going to draw a new x1, y1 line out here. And I'm going to project points B and C out here. And I'm also just going to take one point off of each of the other planes. So I can take point D here as it's on the ground. And I'm also going to project out E as well, just because it's on the ground as well. So locating these points out here, this is E, this is D, C is on the ground here, and B is located at the same height that it is up here in the elevation, which was the 50 plus 35, so it's going to be up the 85. You can measure with your compass or just mark it up here. Either way, you're getting the same result. So this is B up here. I am going to draw on the line BC and just write the words or TL on it as it's a true length. You don't have to write anything on it, but it's handy to remind yourself that that is a true length. So next thing now, we're going to get a point view of this line. To get a point view of the line, you need to look along it. So I need an x2, y2 line that is going to be perpendicular to that here. I'm also going to project out the other points that I've brought up along this way. So D and E. These are also projected out here. Now just readjust the camera there a small bit. Just like so when we were working in this view, I skipped this view and measured from this XY line back. Now that I'm working in this view, I'm going to skip this view and measure from this XY line back. So I'm going to measure from this XY line here back into this view down here for all of my points. So I'm going to just take my compass for that. I'm going to measure from D here back to D in this view. So that's going to be here. Measuring from C and from B, they're going to be the same distance back, so that doesn't really matter. They have to be the same distance back. And I didn't project that point out. So out here is BC. So this is BC. This here is D. And I'm also need this point here, point E. So again, that's going to be the same thing out along here. And this is E. Now, just remember BC is our center. It's the point that is the line that is common to both. So our planes, our lines here need to join D to BC and E to BC. If you joined E to D and not up here, you're not after finding the dihedral angle, and then well, you wouldn't have found the dihedral angle. So just here, going to measure the angle, and I'm getting an angle here of 76 degrees. So you can write 76 degrees in here and write dihedral angle. And that is the completion of part 2, or part B of the question. So now looking at part C of the question, P is a point on the edge BC, which is located at true distance of 55 millimeters from point B. We're asked to draw the plan and elevation of the line DP and determine and indicate the true length of that line. So we're told that it's on the line BC, which is here and up here. this is not a true length line, as it's at an angle up here, it's not horizontal. This is also not a true length line, as this line is not horizontal down here. Conveniently, in part B of the question, we did find the true length of the line BC, and that's this one here. So we already have the true length of BC. All we need to do now is find the point P, which is 55 millimeters away from B. So all we need to do is locate this here. So 55 back here, and that's the point P that I'm looking for. In the question, they asked us to find this point, or the line, sorry, in the plan and the elevation. So I do need to project this point back here into plan. So point P back here onto the line BC. This is it here. And also need to project this up into the elevation. You could also measure this height and mark that up if you wish. This will do the same thing. So this point up here is point P. So just showing you here as well, measuring this distance as this is an auxiliary elevation, I can just mark that height up here as well. That gives me the same point. This is point P. I have not completed part 1 of this yet. I'm asked to draw the plan and elevation of the line DP, so I do need to draw in this line joining from here to here. So this is the line in the elevation. And that's the line in the plan. Part 2, C here is to determine and indicate the true length of the line DP. So again, this is not a true length, nor is this, as it's inclined in this view and it's inclined in this view. So for it to be a true length, we need to either get an auxiliary view or rotate into such a view that it's horizontal in one view, then we'll have a true length in the other one. So I'm going to rotate point P around this way till it's a horizontal line, because if it's a horizontal line in one view, it's a true length in the other one. So rotating point P around here, this rotates up this way. Project this up into the elevation. As I rotated it, I haven't changed the height of P, all I've done is move its position as in this direction. So up in the elevation, it's still going to be at the same height, so I can project from P across to here. That point there is the P in its new position. So if I just draw in this line here, this is the true length. And determine and indicate, so I'm just going to measure it as well, and I'm getting 71 millimeters. So that's part C of the question. Found the true length of BC, we already had that from part B of the question. Found this point down here, which is 55 millimeters down. Projected that point back into my plan, projected from there into the elevation, and then I've just rotated this around here. You could also do an auxiliary view looking in this direction down this way. So the final part of this question, part D, is determine the true angle between the edges AB and BF. This part sounds more complicated than it actually is. And if we look at our piece, if just a set square here, this is the line AB, this is the line BF. I'm trying to find the true angle up here between these two. If I have a true shape of the object, then I automatically have the true angle up here. So it sounds like we need to be finding dihedral angles and all these things between them, but if we just find the true shape of that plane, of the plane ABF, then we automatically find the true angle between the plane between the edges AB and BF. So for this, I'm going to use what in geologic geometries you're going to find the strike. So I'm going to find a point view of my plane, the plane being A, B, and F. I'm going to find a point view of that to get an edge view of it. Once I have an edge view of it, then I can get the true shape of it. So the first thing I'm going to do is I'm going to find a horizontal line on the surface ABF. So a horizontal line here, projecting this across this way. This is a horizontal line. Finding that same line down in plan, so I'm going to project that line, that point, down here. It's on the line BF, so that's this point here. joins back to A. So A to this point, this line here now is the true length, and in geologic geometry, if you were doing that topic, C1, this would be the strike line. So next thing that we're going to do is we're going to find, we're going to look along this, find an edge view of this plane. So I'm going to project the 3 points and this line here. So projecting point A, projecting point F, and point B also. Creating a new x1, y1 line. It's not an x3 or an x4, it's an x1. As it's separate to the ones that are over on this side. Going to locate the height for each one of these. Going to measure again, so working this one, skipping this one, measuring from this xy up. So F is going to be this height here, so I can measure the vertical height of F. Mark that onto the line for F here, so this here is F. Do the same thing for the height for A. This here is A. And same thing then for the height up here for B. So I'm just going to extend the line from B up here a little bit further so it hits my point. So this is B, this was A, and this is F. So if we've drawn this accurately and we found the correct strike line, B, F, and A should form a single straight line, edge view of the plane. And what we're going to do next then is we're just going to get look in perpendicular to this, which will find the true shape of it. So I need another xy line. This time it's going to be parallel to this line. So I'm going to have an x2, y2 line out here. Project all my points perpendicular. And just like we said other places in this video, I'm working in this view. I'm going to skip this view and measure from this xy line back. So for F, I'm measuring from the x1, y1 line back into the plan. It's going to be this distance here. For A, same thing, from the x1, y1 line back to my point over here. This is A that I'm looking for, and from B, it's the x1, y1 line back to point B again, and again measuring from the x2, y2. Label my points, just so I join the correct ones together. This here is A and this here is B. So it's A to B to F. The line is A, B, B, F. So just make sure you are joining the correct points together here. So B to F and A to B. And in here is the true angle between AB and BF. Because we found essentially the true shape if that was a continuous plane, and you can also measure the angle then. So the angle I'm getting here is 61 degrees. And that's part D of the question, and also completes this question.